This is 9-2, Tests and Proportions, the beta lesson. We're going to go through the back half of the PowerPoint. I don't need to read that for you. That's your p-value. Okay? Except what? You had to establish an alpha level first before you collected the data. So wherever the alpha level is, you decide whether you landed in the body or the tail. In a two-sided test, the calculator does this for you. When you choose a two-sided test, it adds the area. The p-value is the sum of those two tails. You don't have to do any calculations. You just have to compare the p-value to the alpha level. And this more closely corresponds to the confidence interval, the two-sided test. So here's an example. Ready? According to the Center for Disease Control, so that's a parameter. 68% of high school students have never smoked a cigarette. So you take a sample, 150 students from the school, and you get an answer of 90 that have never smoked a cigarette. Is that convincing evidence that the claim is not true? Like, can you reject the null? What are you doing here? Wonders whether this national result holds true. That means it's a two-tailed test. She doesn't suspect it's over, she doesn't suspect it's under, holds true. So that's telling you when you write this, it's a two-tailed test. The null is the parameter from the government, and the alternate is not equal to. We're going to use an alpha level of 5%. All you need to do is establish this beforehand. You don't have to worry about doing anything on your calculator. So conditions, SRS, 150 students is less than 10% of the it's a large high school, we'd expect there's more than 1,500 kids in there. And then 150 times P sub 0, because you're doing this before you collect the data, is greater than 10. And really, Maddie, you only have to do this one. The sample size times the smaller proportion. Because if that's bigger than 10, then the larger one has to be bigger than 10. You can't just stop here. You'd have to say, therefore, 150 times 0.68 would also have to be bigger than 10, but you don't have to do the calculation. What's p hat? P hat is the statistic. So you are at 0.60. How far is the statistic from the null? And the step is based on the null. So you get this z-score. Except what happens? The calculator does this for you. See this red shaded area? That's 0.0179. But the calculator is going to double. It's going to double it for you because you picked a two-tailed test. And you compare this number to 5%. It's lower than 5%. You are in the tail, so you reject the null. See where they did this? Normal CDF, and they went from negative 1,000, arbitrary negative number, to negative 2.1, the z-score. And they doubled it because they did it the long way. If you do stat test, it'll do it for you. That's a big deal. Why? Because if you mistakenly double this number, then you're going to be over the alpha level. So you need to pay attention to details. We reject the null. We have evidence that the proportion who would say that they've never smoked is different from what the CDC claims. So let's go to the calculator here. Let's pause this, make sure we understand what's happening. Go to the calculator. You go to the calculator. You go to stat, test, ready? It's a one proportion Z test. How do I know? Well, it's going to be easier once we get into chapter 10 when comparing two separate proportions. But remember, the Z's go with proportions, the T's go with means. So I want 5. So what's happening here? The null is 0.068. That's what the CDC said is the proportion of children who claim to never have smoked a cigarette. Now I put in the data. 90 said they never smoked a cigarette. Sample size is 150. Choose a two-tailed test. Right? And I get down here and I calculate it. There's the Z-score. But here's your p-value right here. It's less than 5%, so you reject the null. Now, first thing is, if I go back here, don't you do this, just watch. If I go back to stat test 5, and I were to change this to a one-tailed test, that's why it's important you decide if you are clear on this before you start typing stuff on the calculator. You get the same Z-score, but you get half the p-value because you asked the calculator to do a one-tailed test. Okay, well, you're going to still reject the null. It's less than 5%. Correct, but if you go the other direction, you got to be careful about this. It's the same Z-score, but what happened was you asked the calculator to do a one-tailed test there. Stat, test, 5. So we're going to go back here, and look what happens now. If you go second quit, and you go to stat, test, and scroll down to a one proportion Z interval. Remember we did this in chapter 8. It's one proportion. Z is because it's proportions, and it's an interval. Enter. Look what happens. The calculator brings forth the numbers. It brings them forward from your stat test 5. Because those two go together. Stat test 5 and stat test A go together. One's a test and one's an interval. So the calculator loaded that data for you. And I get down here and calculate it. Ready? Now what? The confidence level's 5% or 95% because that corresponds to a 5% alpha level. If it's a two-tailed test, then one, take away the alpha level is your confidence level. Think of it this way. The alpha level is the area in the tail before you start, and the confidence interval is the area in the body. Calculate. Look what happens. You get this interval from chapter 8. But what do you notice? P sub 0 is 0.68. It's outside the interval. So we would reject the null. See, the difference is the interval's centered around P hat, the 6/10. But it doesn't extend out to include P sub 0. And because P sub 0 is not in its interval, we reject the null. So you're getting the same conclusion, whether you did an interval or a test. That has to be clear to you. The interval and the test are not going to contradict each other. But The test is centered about the null, and the interval is centered about the statistic. Yeah, I wasn't really crazy about this slide. You're too detailed here. You're going to confuse you. Right? So those are the bullet points that we started with yesterday. But again, the top one is just the conditions. The conditions on the template. Ready? SRS or random assignment of treatments if it's an experiment. The sample size in an experiment, the sample size times the null has to be greater than 10, and the sample size times 1 take away the null has to be greater than or equal to 10. And your sample has to be less than 10% of the population because of sampling without replacement. In this case, the test statistic is your z-score. The p-value is the probability of getting the z-score you got or more extreme. When you say more extreme, that's why that tail is getting shaded in. The test statistic you got or more extreme by chance alone, meaning by sampling variability had the null been true. And the p-value gets compared to the alpha level which you picked before you began. Okay? So, the only thing on the PDF is this. If it's a two-sided test, the null is p equals something or chapter 9 mu equals something. And the alternate is not equal to. If it's a two-sided test, use an inequality symbol in the alternate hypothesis. If it's a one-sided test, you use an inequality symbol in the alternate hypothesis. And the way you determine whether it's a one-sided test or a two-sided test is by the wording of the question. So the wording of that smoking question was that the person thought it was not. Didn't believe it was higher, didn't believe it was lower. So you got to read to detail. So we're going to pause the video and have you go to 51 and 53. Okay, so here we are, 51. The conditions, SRS, sample size times p sub 0 is greater than 10. Sample size times 1 take away p sub 0 is greater than 10. And then our population is more than 10 times the sample size. The null is that the true proportion is 6/10, 60%. The alternate is not equal to. So when you say not equal to, you don't have to write two tails, but it doesn't hurt you to write it. So what is the z-score? The z-score, and again, remember this p here, for whatever reason, that hat's not showing up. P hat is your sample, 86 out of 125. Subtract 6/10. Well, 6/10 of 125 is 75. And then the step is based upon p sub 0. You're writing this out just so you understand what's going on. In reality, you can go right here. See, all you're doing is saying the null is 6/10 in stat test 5, and your sample is 86 out of 125, and you're picking a two-tailed test. So what happened? You got a p-value of 0.0446. your p-value is less than 5%. You reject the null. There is evidence that the true proportion of teen drivers who pass the test is not 60%. Okay? Then if we went here for 53, we did a confidence interval. Now remember, it brings it over there. So as soon as you put the data in stat test 5, it brings it to stat test A. And in 51, we rejected the null. But here's the interval. See, the interval does not include the null, 60%. So you would still reject the null whether you did a test or an interval. But what you're trying to get your mind around here is this. In 53, the confidence interval is centered about p hat, which is 86 out of 125, which is about 69%. In 51, the test was centered about the null, p sub 0 to 60%. But in both scenarios, we rejected the null. Because why? If we back up to 51, this p-value, right down here, is less than 5%. If the p-value is small, we reject the null. Same data. The null is that the true proportion 6/10. It's outside the interval. We reject the null. So those two approaches will complement each other. Okay?